Musa Usman Ibrahim, a teacher and a tutor with Harvard Professional Home Tutors. Today we are looking at chemistry, and our topic is balancing of chemical equations. The topic for today is balancing of chemical equations. Now, a chemical equation is a representation of a chemical reaction. A chemical equation is a representation of a chemical reaction using the symbol of elements and the formulae of compounds. So in chemistry, we have a way of representing chemical reactions using chemical equations. Now, the chemical equation is a summary of the reaction using symbol of the element and formulae of the compounds involved in the reaction. Now, these are examples of chemical reactions represented with chemical equations, but the equations are not balanced. So what we're going to do today is we are going to balance all these chemical equations. Now, why is it that it's important that we balance our chemical equations? It's very important because all chemical equations must comply with the law of conservation of matter. I said all chemical equations must comply with the law of conservation of matter. The law of conservation of matter states that matter can neither be created nor destroyed. It can only be changed from one form to another. So if you write a balanced chemical equation, or rather, if you write a chemical equation and it's not balanced, what it means is that atoms have been created or atoms have been destroyed, which is not possible. The equation must be balanced to comply with the law of conservation of matter to show that nothing is created and nothing is destroyed. So we are going to balance the equations we have on the board. The first one is a reaction between carbon and aluminium to form aluminium carbide. A reaction between carbon and aluminium to form aluminium carbide. Now, if you look at the equation, it's not balanced. These are the products, or this is the product, while these are the reactants. Now, when you look at the product, aluminium carbide, you have 4 atoms of aluminium and you have 3 atoms of carbon. But if you look at the reactant, we have only 1 atom of aluminium and we have 1 atom of carbon and then 1 atom of aluminium. So what do we do to that? We have 3 here. So if you put 3 here and we have 4 here, if you put 4 here, the first equation is now balanced. 3 atoms of carbon, 4 atoms of aluminium. Here we have 4 atoms of aluminium, 3 atoms of carbon. So the first equation is now balanced. We now look at the second one. The second one is a reaction between magnesium and nitrogen gas to form magnesium nitride. The equation is of course not balanced. We have 1 atom of magnesium here, 3 here. We have 2 atoms of nitrogen, 2 atoms of nitrogen here. So what do we do to balance this? We put 3 here. So the equation is now balanced. 3 atoms of magnesium, 3 atoms of magnesium here. 2 atoms of nitrogen, 2 atoms of nitrogen. How do we know the equation is balanced? Just like I did now, you do an atom count. We call it an atom count. You count the number of atoms of every element participating in the reaction after the arrow, that is the product, and then you count the number of atoms of every element participating in the reaction before the arrow. So here we have 3, here we have 3, it's balanced. 4, 4, so this is balanced. 3 here, 3 here, 2 here, 2 here, so the equation is balanced. We now go to the third one. The third one is a decomposition reaction involving potassium trioxochloride 5. When potassium trioxochloride 5 is heated, normally it decomposes to give a potassium chloride and oxygen gas is released in the process. So the equation is not balanced. We have 3 oxygen atoms here, we have 2 here, we have chlorine and potassium. So how do we balance this? Since we have 3 here, we have 2 here. That means we must add something here to try to meet up with what we have here. So if you put 3 here, 3 times 2, we have 6 atoms of oxygen. Then you put 2 here. 2 times 3, we have 6 atoms of oxygen, 6 atoms of oxygen. So oxygen is now balanced. We now look at the chlorine and the potassium. Potassium, 2 atoms, chlorine, 2 atoms. Here we have 1, 1. So we just put 2 here, So the second equation is now, the third equation is now balanced too. If you do the atom count, you find out that it's balanced. 2 potassium atoms, 2 potassium, 2 chlorine atoms, 2 chlorine, oxygen 6, oxygen 6, so it's balanced. Then the fourth one is a reaction involving lead 2 sulfide and hydrochloric acid. The products are lead 2 chloride and hydrogen sulfide gas. The equation is not balanced, so to balance it, since we have 2 chlorine atoms here, you put 2 here. So lead atom is 1, here is 1, sulfur is 1, here is 1, hydrogen here is 2, here is 2, chlorine 2 and 2. So the fourth equation is balanced. We now go to the last one, a reaction between ammonia gas and oxygen gas. Ammonia burns in oxygen to produce steam or water vapor and nitrogen gas. So if you look at the equation, it's not balanced. We have 2 nitrogen atoms here, we have only 1 here, we have 2 hydrogen here, we have 3 here. So how do we balance the equation? We put 4 here. If we put 4 here, nitrogen atoms 4, then we put 2 here, so that 2 times 2 will make it, we put 2 here. So we have 4 nitrogen atoms, 4 nitrogen atoms. Then for the hydrogen, 4 times 3 is 12, so we put 6 here. So hydrogen atoms are now balanced. When oxygen, we have 6 atoms, so we put 3 here. 3 times 2 making 6, 6. So if you look at the equations now, they are all balanced. By the time you carry out an atom count for all the equations, you notice that what we have after the arrow, that is the product, always equal in terms of number of atoms to what we have before the arrow, that is the atoms. Thank you for watching. Until you see us again in the next video. Thank you.